let's go through LeetCode 2872, maximum number of K-divisible components. For this question, it give us a tree. We use ages, which is two-dimensional array to represent tree, and also this tree has n nodes. And for each node, there is values associated with it. So to ask how many components we can separate the tree, so that for each components, it will be divisible by k. So ask us what's the maximum number of components we can split. So let's look at example 1, right? So we'll say this value is 1, this is 8, this is 1, this is 4, and 4, right? So the maximum we can split it for this edge, cut this edge, right? So that this is 6, this is 12, both divisible by 6. So the maximum we can cut is 2. Maximum components is 2. So for this question, how can we consider instead of simulate those kind of cut the edge, we can think differently. Let's look at, for example, we have a tree, right? We have a tree. Assume this part is divisible by k, right? And for example, one of the leaf is divisible by k, and we have this subtree is divisible by k, right? So totally, it will be how many components? So if in this case we need to cut here, here, and here, right? So it will be separate as one component, two components, and this is 3 components and 4 components, right? So let's say this part is divisible by k, right? So we'll say this subtree, I use a red part, is divisible by k, and it has this a subleaf, right, which is in this tree, is divisible by k. So the rest is also divisible by k, right? So this problem is converting to counting how many subtrees are divisible by k, right? So if we are, instead of doing count the components, we can just count how many subtrees are divisible by k. For example, we have a leaf here, 1, 2, and 3, right? So if this subtree is divisible by k, then the rest is also divisible by k. And this question says that all of the sum is divisible by k, right? So we do the post order traversal, and for the DFS, right? We post the order traversal. What we return is for this subtree, when it divided by k, the remainder, right, will be the remainder, because the remainder will be passed into its parents. So as long as there is a subtree divided by k, we just increase our result by 1, right? So the total will be how many subtrees is divided by k. So if we do these transitions, this question will be very classical post-order traversal, or DFS, right? So let's begin to write code. It gives us an age, right? So we need to convert this into tree. So we can use a list integer array equals new array new list. And then we can use another one called tree set O, arrays, set O, and the tree in the new should be there is already K, right? So we use L goes to new array list. So for every age in ages, what we do is that we need to have tree age 0. We're going to add age 1, right? And also tree age 1, we need to add age 0. Then we can put a reference result, right? Plus new int 1. Then we DFS post order tree. So the DFS result will be for this node, right? For this node, for the root, what is a reminder when divisible by K, right? So for tree, we know we can set any node as root. So for this one, we can just set a 0, right? And because we use array to represent tree, so we need its parent as parameters. So we need values and we need a result. In the end, we need a return result 0. So for this DFS private DFS, we return for this subtree the reminder. So will be 3, and we need a current, right? Current, and we need a parent, and we need a passing. For this one, we also need the K variable, right? Int K, because we need to divide by K, and we need passing the values array, and we need passing the result array. So so if this is a leaf, right? So if how can we judge whether this is the leaf? If tree dot current dot size equals 1, right? And this is not enough because it is possible this is a root, right? Because the root can also have only one edge. And let's say this tree dot current dot get 0 equals parent, right? Then this is root. So what we do is that for this tree, right, we need to return values parent mod K, right? So for this one, mod K, right? So the things that let's say if this values current mod K equals to 0, right? Means we have a leaf which is divisible by K. We can separate it as one component, which have result 0 increased by 1. So this is for the leaf, and for our current tree, what we do is that we need a sum variable equals we are going to add our current value, right, for this node value. So we should have values current multiplied by K, right? And what we do is that for int next in tree current if next equals parent, we need to continue. And then we'll have sum, just a plus equal to every child. That is DFS tree. Next, current K values result. Right. So for this result, if sum mod by K equals 0, then we are going to have result 0 should increase by 1, right? In the end, what we need is just return sum mod by K, right? So this will be the code. The time complexity will be O(n), space complexity will also be O(n). Um, let's write the Python code as well. So let's say tree, we need to convert this two-dimensional list to be tree, right? So use a list for in range A. For age in ages, we're going to have a tree age is 0 up in the age 1, right? And also this tree age 1, which should append age 0. Then we can have result equals this, right? As by reference. Then we need DFS should have tree parent uh, K values result. In the end, we just return result 0, right? Let's define the DFS. DFS, we need to have a tree, which is a list of list int, right? And we need a parent, which is an int, parent, which is an int, and k, which is an int, and values, right? So that is the list of int, and the result is also a list of int. And this one also returns int. So we'll say if this length tree parent equals 1, and tree parent is 0 equals parent. So let's say if values parent mod k equals 0, we should have result 0 plus equal to 1, right? And also we need to return values parent mod k, right? And for DFS, we have defined some value. Yeah. equals values current multiplied by K. Then what we do is that for next um, in tree current, right? So if next equals current, we need to continue because we already traversed this one, right? Continue. And then what we do is that we just have some value is plus equal to DFS tree next node, right? And current K values result. So in the end, what we say is that if was S value mod K equals to 0, right? We should have result there should increase by 1. And then in the end, we just return S value mod K. If length tree. The time complexity will be O(n) and the space we use a map or list, right? It's linear, it's also one.